High availability is central to maintaining business continuity in Azure-based solutions. By replicating workloads across distinct physical or logical components, the risk of downtime is minimized. This concept is vital when configuring Azure virtual machines, VMs, as disruptions may stem from hardware failures, software patches, or unanticipated events. In earlier units, we covered how to create VMs, modify configurations using resource manager templates and bicep files, and manage disks. Building on these skills, this section examines how availability zones and availability sets can enhance Azure VM resilience. Each approach addresses different failure scenarios while ensuring uptime. These principles guide resilient Azure infrastructure design. Availability zones distribute Azure resources across separate physical data centers within a region. Each zone has independent power, cooling, and networking, reducing single points of failure. When deploying VMs to multiple zones, workloads can continue operating if one zone becomes unavailable. This design helps mitigate localized disasters or outages, enhancing fault tolerance beyond the scope of a single data center. Earlier discussions about resource manager templates and bicep deployment strategies apply here, as you can specify which zone each VM or resource instance should reside in. The resulting topology supports robust architectures essential for mission-critical applications. Zone placement requires careful planning steps. Availability sets group VMs within a single data center, but distribute them across fault and update domains. This configuration ensures that planned maintenance and infrastructure failures do not affect all instances simultaneously. In earlier sessions, we explored modifying VM attributes using templates and bicep files. The same concepts apply here as you designate a specific availability set resource for your VMs. By diversifying across multiple fault domains, you mitigate the risk of hardware-level issues disabling every instance. Similarly, update domains stagger patch deployments, preventing all VMs in the set from restarting together. Availability sets thus deliver structured resilience against localized disruptions. Fault domains represent a potential single point of failure in a data center, such as a rack with shared power or networking. Azure places distinct VM instances into separate fault domains to limit the impact of localized issues. Meanwhile, update domains define groups of VMs that undergo maintenance or patching simultaneously. Distributing VMs across multiple update domains prevents all machines from rebooting at once, thus preventing service interruption. Within availability sets, Azure automatically assigns fault and update domains. When deploying with Resource Manager or Bicep, these parameters can be adjusted to balance performance objectives, operational requirements, and planned service windows. Choosing between availability zones and availability sets depends on several considerations. If your application requires geo-redundancy or is highly sensitive to data center-level failures, zones often provide superior resilience by spanning distinct facilities. Alternatively, for workloads primarily concerned with isolated hardware failures or controlled maintenance events, sets may offer a simpler configuration within a single region. Budget constraints also influence this decision, as zone-based architectures can incur additional network or data transfer costs. Finally, regulatory or compliance requirements might favor hosting data in specific physical locations, guiding the use of zones. Thorough assessments ensure each deployment optimizes uptime and resource allocation. Azure Resource Manager, ARM, templates allow you to define infrastructure, including VM availability configurations, in a declarative format. By specifying parameters such as location, availability zone, or availability set name, you ensure consistent, repeatable deployments. Building on earlier lessons about editing and deploying ARM templates, you can incorporate these resources seamlessly into your workflow. For example, JSON type Microsoft compute/virtual machines zones 1. Including the zones property distributes VMs across multiple zones, enhancing reliability for critical tasks. Such template-driven approach ensures cohesive versioning and adheres to organizational standards. It also supports parameterization, enabling dynamic resource creation across diverse workloads. Bicep, a domain-specific language for Azure resource deployment, simplifies complex configurations through concise syntax and modular structures. When creating a VM resource in Bicep, you can set availability zone references or link the VM to an availability set with straightforward code. For example, Bicep Resource VM Microsoft compute/virtual machines at 2021-07-01 equals in myVM location resource group location zones 1. This approach supports parameterization and drastically reduces template length. Integrating Bicep with CI/CD pipelines enables iterative changes while maintaining high availability across zones or sets. Developers can also leverage modules for reusability, ensuring consistent policies and naming conventions across multiple environments. Ensuring robust availability extends beyond VM placement. Azure Load Balancer and Application Gateway can distribute traffic across zones and sets, preventing bottlenecks from affecting service responsiveness. Adding services like Azure Backup protects data further, while solutions such as Azure Site Recovery enable cross-region replication for worst-case events. In prior lessons, we explored the interplay between VMs, storage, and networking. Here, integration takes on heightened importance when zones or sets are involved. Proactive monitoring with Azure Monitor tracks performance metrics across distributed resources. Security tools like Azure Policy ensure configurations remain compliant. Coordinating these elements forms a comprehensive strategy for resilient cloud-hosted applications. Distributing VMs across availability zones may introduce additional data transfer costs and latency, particularly if cross-zone traffic is frequent. However, these trade-offs can be offset by the benefits of increased resilience and service continuity. Availability sets typically reside in one facility, minimizing network overhead, yet they offer less geographic redundancy compared to zones. You may optimize costs further by right-sizing your VM instances, leveraging reserved instances, or applying Azure Hybrid Benefit. Monitoring resource usage with tools such as Azure Advisor provides ongoing recommendations for potential savings. Analyzing these performance and budget factors helps effectively align infrastructure choices with organizational priorities. Ongoing maintenance, patch management, and incident response processes must account for the availability zones or sets in which VMs are deployed. For instance, scheduling updates in a rolling fashion across zones or update domains helps maintain operational continuity. Logging and audit trails become more critical when multiple zones or sets are used, ensuring that administrators can trace issues to specific domains. Periodic health checks and readiness probes validate that each instance can handle the production load. Additionally, scaling strategies might vary. Auto-scaling rules should consider zone or domain distributions. These operational details uphold the reliability targets set by your deployment.